Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control System. I have already done Module 1 and Module 2 videos and already uploaded. They are available in my channel. If you have not checked out, please do check out. And Module 3 also I have done many of the topics and already uploaded. Today I am going to do a new topic in this video. I have already done till analogous system, and then I have already uploaded 2 videos based on these 3 topics which we have discussed. Now in this video I am doing block diagrams. A block diagram of a system is a pictorial representation of functions performed by each component and of the flow of signals. It is nothing but picture representation. Block diagram is what? Picture representation of the functions performed by each component of that system and the flow of signals. Here if you see, there is a transfer function which shows arrow heading point towards the block indicates the input, that is R of t, and C of t as output. This is the reference input. C is known as the controlled output. Controlled output. Okay. So now we will see some of the operations. First we will see the addition and subtraction operations in this A, B and C. If you see here, this is the reference input. This is the output of the summing point. This is the summing point which is connected with the output, that is C of t, C of s in a feedback. Here as they are both plus, you will take error E of t is equals to R of t plus C of t. And for that respective Laplace transform also written there. And for B it is minus. Everything is same, but we are going to minus. E of t is equals to R of t minus C of t. Why? Because here it is minus. So for here also respective Laplace transforms are mentioned. Here they have took two reference inputs as R1, R2 and C of t, and addition for if there is minus you will put minus, if there is plus you will put plus, same. And next is a multiplication. For summing point, if you put R of t and C of t with no plus or minus, if there is no plus or minus, present, then you will multiply, that is R of t into C of t, R of t into C of t. Then there is a this is called as takeoff point for the block diagram. This is known as takeoff point. Okay, this is the main basics. Then this is a closed loop system. This we have already seen in the classification of system. What is closed loop system? Where the output is feedback to the input to reduce the error. Where here R of t is the reference input, C of t is the output controlled variable, and G of s is what? Forward path transfer function. H of s is the feedback path. Why? Because it is feedback. B of t is the feedback signal. E of s is the error signal. And this is takeoff point, this is summing point. For this transfer function is nothing but you can write as G of s by 1 plus G of s into H of s. Any block diagram, if it is in this way, you can reduce it to transfer function. It is formula, that is G of s by, here if it is minus you will get here plus, here if it is plus you will get here minus. Okay, keep that in mind. We will see how this G of s by 1 plus G of s into H of s has been came, that how that formula has come in the future slides. Here this is the equation. So how we got this equation, we will see the proof. Open loop transfer function where there is no feedback, then the formula is G of s into H of s. And transfer function, that is not P of s, that is nothing but closed loop transfer function of a system, is output by input. What we have done for mechanical, rotational and translational system for finding transfer function, what I told, output by input. Here output is C of s and input is R of s. So you will take output by input. Now how to find the transfer function equation, you will see. From figure you know that this C of s will be the multiplication of E of s into G of s. Then B of s, the feedback path will be this C of s into H of s. Okay, then this E of s is what? R of s minus B of s. Why? Because minus is present here, so minus B of s. After writing this, you can see that you know B of s and E of s. So you can substitute here. C of s is equals to G of s into E of s is what? R of s minus B of s. Again, you know B of s here. If you substitute B of s here, C of s into H of s, then you will get G of s into R of s minus G of s into H of s into C of s. Then by taking this left side, then C of s will be common. You get 1 plus G of s into H of s, that is equals to G of s into R of s. From this, what you can write? You can write output by input. Why? Because you have C of s and R of s separately. So C of s by R of s will become G of s by 1 plus G of s into H of s. I hope you understood why this G of s by 1 plus G of s into H of s has come. Here if it was plus, here it will become minus. Keep that in mind. Everything is same, that minus will change. Why? Because in this equation also, what it will become? R of s plus B of s. So this all will be plus plus. Understanding? So last it will become minus. So keep that in mind. If they ask proof, you can draw this diagram and give this proof. To draw a block diagram for a system, we need a procedure for drawing the block diagram. How we can draw a procedure? There is a procedure for drawing the block diagram. We need to keep in mind is we should write first differential equation for the each component, then take Laplace transform, then do each equation give one section of block diagram, output of one section will be input to the another, then various sections are interconnected to obtain overall block diagram of a system. What we should do? From the circuit you should write the differential equation, then take Laplace transform, same like mechanical translation and rotational system we have done, no, same like that. We need for procedure to draw block diagram. Okay, write differential equation, take Laplace transform, then one separate components have different Laplace transform equations. One block diagram is the output, is the input to the other. So by connecting like that, you connect all the block diagrams into one and form a block diagram, which is the whole system. We will see one of the example for this. Here example is, this is the question, a question or the example. Here it is in the form of electrical circuit. You can write the current from this. Total current I is equals to voltage EI minus E naught by resistance R. Okay. Then E naught across the capacitor we need to find. E naught is equals to 1 by C integral I dt is the formula. After writing that, we need to take Laplace transform. We will write in terms of S terms. I of s is equals to E1 of s minus E naught of s by R. E naught of s is equals to 1 by, for capacitor we will write multiply with S into I of s. Why? Because integration means nothing but 1 by s it will become Laplace transform. So 1 by s. After writing, we can separately draw diagram for both equations. If you see, it is E1 of s by E naught of s. If you take E1 of s as input minus E naught of s as the feedback, then 1 by R will be the block. So I of s will become E1 of s minus E naught of s minus E naught of s. Understanding? So you will get the same equation. If you draw, it will be in this way. If it is E naught of s is equal to 1 by Cs, Cs into I of s, then E naught of s will be the output, 1 by Cs will be the block diagram, and I of s will be the input. So if you then you need to combine these two diagrams so that it will be a whole diagram. E naught of s is the output, E1 of s is input. So from output to input, the feedback need to be mentioned. 1 by R and 1 by Cs should need to be also mentioned in between. So this is what the procedure what we have seen in the previous slide. First we will write the differential equation, write the Laplace transform. For separate component we will write the diagram and connect both diagrams to become a very the whole overall block diagram of the circuit. Understanding? Then block diagram reduction. Now we have seen what is block diagram, then procedure, and how to make the block diagram, the example. Now we will see how to reduce the block diagram. The following points to be remembered is the product of transfer function in feed forward must be same, remain same, and transfer functions around the loop must remain same. Around the loop must be remain same, and in the feed forward also it should be remain same. There are some rules which are very important for solving the problems. There are some 13 rules. We will see one by one. if the blocks are in cascade, that is nothing but in series, G1, G2 or G2, G1, anyway it is, then the input and G1 will be multiplied and will be the output X1, G1. So for this G2, it will become X1, G1, G2. In the same way, X1, G2 and this output will become X1, G2, G1. Either ways, it is you are getting the same output X1, G1, G2, X1, G2, G1. Anyway, is the same. So they are telling this both the ways if there is connected in cascade, the equation will be in this way. Okay, G1, G2 is multiplied and we'll write in the block diagram. Is the combining blocks in the cascade, combining blocks in parallel. If you see here, this is the forward direction. Keep that in mind. It is not feedback. Feedback will be from output to input. Okay, feedback is not here. Here it is parallel. Why? Because from input to output only it is going. Nothing but you should consider it as parallel. So G1, G2 need to be added or multiplied or subtracted based on the sign present. Here G1 is anyway plus. G2 sign here is plus or minus. Plus or minus. If you are given plus, you will take here plus. If here is minus, you will take minus. So only G1 plus or minus G2 is written. Understanding? So this is the parallel way you need to write, that is G1 plus G2 or G1 minus G2, and input is X1, X2 is the output. Then you have moving the summing point after a block. How this is done? There are some sums where there is a requirement of moving the sum point to the right side. Why? Because it should be easy to reduce, no? So when we are moving this to right side, then what it becomes is that everything will be same, but you are going to add a G block to that, this signal. Understanding? If you are moving right, keep that in mind. If you are moving that summing point left, nothing but ahead of a block, then what it happens, you need to multiply or you need to add 1 by G as the block in that signal. Keep that in mind. These two are very important. Then now summing point is done. If you move takeoff point to the right side, then it will be 1 by G. You need to add to this signal. If left side, if you are shifting, that is nothing but takeoff point is ahead of a block, then you need to multiply or add a G to that signal. Keep this in mind. Just the ulta for summing point. I'll make a easy way to remember for you. Summing point is like this. Now, if summing point, if you're moving right side of the block, then you should add G block. If you're moving left side to the block, you should add 1 by G block. If it is takeoff point, if you're moving right side of the block, then 1 by G you should add. If you are moving this to left side, then G block needs to be added. Just ulta. Right and right, this is G and this is 1 by G. You keep any of the one thing in mind and the other thing the opposite of that. Keep that in mind. Okay, summing point and takeoff point. If it is shifted from block diagram from left to right and right to left, how to change? This is very important. It will affect the whole transfer function final output. Then eliminating feedback from the loop. If you want to eliminate the feedback from this loop, for example, eliminating a feedback, you want to eliminate this feedback, then what we should do, take the transfer function, nothing but G by 1 plus or minus GH, nothing but what we have seen the proof, no, same. Next, what you have, interchanging summing points. If you want to interchange the summing points, that is also possible. How? If you see here, input is given as x3. If you are interchanging, this x3 will come, this whole summing point and x3 will come this side. This whole thing will go right side. Just the interchange. This will go to, if you consider this as 1, this as 2, this will become 2, this will become 1. That is nothing but interchanging. Okay. Then splitting a summing point. Splitting a summing point is nothing but here there is x1, x2 and x3, x1 plus x2 plus x3. If it is minus x1 minus x2 minus x3. How we can split? We can split this x2 and x3 as separate summing points. If you take this separate summing point x2, then it will become x1 plus or minus x2. Again, if you add plus or minus x3, it will become x1 plus or minus x2 plus or minus x3. These two are same, no? So separately also you can split the inputs. Okay. Then moving the takeoff point ahead of a summing point. If you are moving the takeoff point ahead of a summing point, if you are moving this takeoff point ahead of a summing point. It is not a block from ahead of a summing point that I mean. So you should add a summing point there. Then if you are moving a takeoff point after a summing point, if you are moving right side, then also you should add a summing point to that signal where which takeoff point you are moving right side. Okay, removing a block from a forward. If you are removing the block from this forward path, nothing but if you are removing this G2 for example, then what you should do, you should add this to G2 and divide by G2, the G1 by G2. If you are removing a block from a feedback path, if you are removing block from this feedback path, then H used to be, need to be 1 by H need to be added and multiply that H to this forward path block, forward transfer function block. Understanding? You need to keep these all 13 points in mind for solving the problem. Please keep that in mind. These rules are very important. Why? Because block diagram reduction method is little bit tough. Why? Because you need to understand these all rules. Keep in mind where to use what you should know. Then only you will get the correct answer. So I'm tough in the sense it's easy, but you should know these formulas or these methods of moving the summing point or the takeoff point, or the formulas how to check the, if you want to remove the forward path, feedback path, you should know this rules so that it will be easy understanding. So please do practice. Now we will see the sums based on the discussed procedures of the block diagram reduction method. Obtain a transfer function this for this block diagram by block diagram reduction method they are asking. Okay, if you see here, the block diagram is little bit like the, complex. If you see in diagram question itself, they highlighted this. If they are not highlighted also, you should know that that needs to be first calculated. Why? Because if you calculate this first only, then only you can calculate next. Why? Because the next things can be calculated if you are clear with this, then this with this block, then you have next block like that. So from inside out you should come. We will see how to do that first. If you see here, these two are in what? Parallel. See, this is not feedback path, it is forward path, because from left to right, that is output to input, it is connected. So what happens, as here it is minus, you will write G2 minus G3 and into G1. Again, if you see, these two blocks are in what? In cascade. So you can multiply them. Nothing but you will get G1 into G2 minus G3. Then what you have here, this plus plus and plus minus. Here is there is H2. Here what we do is we are going to what? Make this summing point to go what? Left. If we are moving left, what we will do? We will add H2 to that respective block, right? So by moving that you will get H2, H1, then G4, H2. Understanding? G4, H2. See, what we are doing, we are moving this plus point to left side. Means what? We need to add H2 to the that respective signal. So we are adding that, or then H2, this H2 block will come on the right side. Then if you see, these two are in cascade, these two are in cascade. Then what happens? This will become H1, H2, this will become H4, H2. Then what we can do is, we can write, we can exchange or interchange these two summing points. So it will become easy. How? See, this H1, H2 is connected to what? Plus plus. But they are interchanging means it should connect it to plus minus. So if it is connected to plus minus, this G4H2 is connected in forward direction. It should be connected to what? Plus plus. Why plus plus? Why? Because we are interchanging. So for this plus plus we connect, for this we connect directly to minus minus. So we can separate the block diagrams for reduction. Understanding? Then this becomes again parallel. So 1 plus G4H2. This becomes the feedback path as it is from output to input. So what we should do here? we should do the what G by 1 as it is here minus 1 plus GH. But here if you see in the place of G what it is there, G1 G2 minus G3. So G1 into G2 minus G3 by 1 plus G, what is G? G1 into G2 minus G3. What is H? H there. H is H1, H2. H1 and H2. If you calculate this, what you will get is, if you calculate the equation what I told now, then you will get as, see, 1 plus G4H2 into, you have written this, no? After writing this, again these two are in cascade, you will multiply these two. After multiplying, you will multiply this whole thing with this and separate multiplication you will do. Then C by R will become this transfer function. This is the overall transfer function. This is just a multiplication, so I am not showing in clear. Next question. Obtain the transfer function of the feedback control system shown in figure by block diagram reduction technique. If you see here, this diagram, G2 they are highlighting. Even though they are not highlighted, you should know that if you shift this shift point to left side, it will become easy, right? Why? Because here there is a overlapping, so we can't calculate directly. So if you shift, what happens? This shift, this takeoff point is shifted what? Left side. Then if you are shifting it left side, what happens? You are going to add G2 to the block here. Understanding? You should add G2 to the block. Why? Because you are shifting left side. You are shifting the takeoff point to left side, means what you should do? You should add G2 to that signal. So what happens? These two are in cascade form. These two are in cascade form. So what we can do? We can multiply. So G2 G3 plus again this G2 G3 in turn are in parallel. So G2 G3 plus G4 you can do and G2 H1 you can write. From this, after this what you can do? If you see, if you analyze this block diagram, if you see, I highlighted this block diagram where what you can do is you can shift this takeoff point to this. Why? Because all three takeoff points will be same then. So if you shift here, it will become easy. If you shift takeoff point to the right, what you should do? If you are shifting takeoff point to this block diagram right, this whole term need to be divided. So I have divided. If it is right, we should divide. No, so I have divided. After dividing, if you see the whole diagram, this diagram is in what? Transfer function you can take. Then in turn you can multiply. We will see the next step. So this, you got the transfer function from the previous. That is nothing but G2 G3 plus G4 plus G2 G3 plus G4 H2. Why? Because this is the G there is present and 1 plus this is G, G2 G3 plus G4 and H2. Then this whole diagram is in cascaded with G1. So you can multiply with them. If you multiply, you will get G1 G2 G3 plus G1 G4 by 1 plus G1 G2 H1 plus G2 G1 H2 plus G4 H2. How you got this is, again if you see, this is in what? Feedback. After multiplying with this, you can do the transfer function, nothing but G1 G2 G3 plus G1 G4. This whole diagram whatever you get, no, that is the G by 1 plus, again you need to multiply this G term into H term is what? G2 H1 by G2 G3 plus G4. See, I will write here if you are not understanding. See, after multiply you will get G1 G2 G3 plus G1 G4 by 1 plus G2 G3 plus G4 into H2. This is the whole G by 1 plus the whole G term whatever is there, no, that you should write here. Nothing but G1, G2, G3 plus G1, G4 by this numerator term. I am just mentioning numerator term into this H term. This is the H term. This is the feedback. No, G2 H1 by G2 G3 plus G4. This whole term you will write here. Understanding? Nothing but the whole thing you should understand here is the whole equation. This is G. Keep that in mind. This is feedback. So you are taking this formula. If you consider this as whole G, this whole thing as H, it is G by 1 plus GH only. In place of G, write this whole equation. In place of G, write this whole equation. In place of H, write this whole equation. Understanding? After that, if you calculate, go on reducing, you will get this equation. Again, lastly, there is a feedback with that is 1. If there is no feedback present, it is not considered as 1. Then what to do? G1, G2, G3 plus G1, G4 plus 1 plus this G1, G2, G3 plus G1, G4 by 1 plus G1, G2, H1 plus G2, G1, H2 plus G4, H2 into 1. See, what they have done here is, this whole thing is now G. This is H. H equals to 1. What happens? G is equals to 1 plus G into 1. So, G, you will take this, G by G plus G by 1 plus G into 1. So, this is the whole G. You will write in this G terms, and 1 anyway you will get, into H is not there, so 1. If you do that, then you will get the given equation. This is what the final equation you will get. Then simplify the block diagram shown in figure and obtain the closed loop transfer function. They are asking for C of S by R of S. Nothing but what we are doing till now. The same. If you see here, if you move this point to here, it will become easy, no? We will see. See, this takeoff point is moved left side. So you need to add a G2 block and multiply it. Why? Because it will be in cascade directly. G2H2 is written. Now if you see this G2 and G4 are in parallel, you can add them. G2 plus G4 it will become. Then again in turn it is in cascade. So G3 into G2 plus G4. Understanding? After that, if you see, this is also connected to H3. Okay. And this G2H2 is there, no? They interchanged this. If you interchange, see, these two summing points are same. You can interchange. By interchanging, what happens? This H3 is connected to this point. This is connected to this point. So again, this whole thing will become what? Transfer function kind formula. It is like closed loop. You can do G by G plus G by 1. G by 1 plus GH. If you consider this as whole G and this as H, what you will get? G2, G3 plus G4 by 1 plus, you will get G2 plus G4 into G3 into H3. You will get this. After getting this, you know that G1 and this whole block are in cascade. Before that, you need to see this first. Why? Because this is first remaining. So, first you will find in this way only. Same like this way. This whole thing you will treat as G. This whole thing as H. You will get as G by 1 plus GH. You substitute the G term and the H term. So, after reducing it, you will get this. After getting this should be multiplied with G1. So, you will get the whole equation like this. But there is this loop also, 1. That is also considered in this final equation. See, if you consider this whole thing as G, this as 1, the formula will become 1 by G by 1 plus G into 1. Why? Because H is 1 there. Okay. If you substitute that G term into that equation, then you will get this equation. The final transfer function is this. Understanding? Next question. For the system represented by the block diagram shown in figure, evaluate closed loop transfer function when the input R is at station A and at station B. They are asking when input is station A, find the transfer function. When input is station B, find the transfer function. Output by input. When we are considering station A, we will make station B 0. Then if it is considering station B, we will make station A 0. Okay, we will see that how. First we will consider station A. Station A means this will be the R input, difference input, and the B point we have removed. There is no B point. Okay, after removing that B point, the summing point will be directly connected to G3 only. If you see here, is it easy to solve? No. There need to be some changes to be done. Then only we can do. How we should do? If you see here, this point, this takeoff point can be shifted to right side. Then it will become easy. If you are shifting right side, what we should do? Takeoff point to the right side. Then you need to divide that respect to block. So H2 by G3 you are dividing. To which point you are shifting, no? To that point only this block need to be divided. So we have divided. After dividing, if you see, this looks like the feedback loop. For feedback loop, what we should do? G2, G3. First G3 by 1 plus G3H1. This whole thing will be in cascade to this. So we multiply G2 to it. Again, this whole thing. This if you can see, this is the feedback loop. So you can consider upward or upside also, downside also. After completing this which is remaining upside, no, that you will take down. Again this becomes a closed loop. Again you will consider this as H, this as G, this as H. After considering, again you will do the G by 1 plus GH. Why? Because here it is minus. You will do that. See, this is G term 1 plus G term H term. After doing this, again these both are in cascade. You will multiply that with G1. If you multiply this G1 and do some cancellations, you will get this. Again there is another feedback loop. Again you will consider this whole thing as G, this H as H2 as H. You will get G1, G2, G3 by 1 plus G1, H1 plus G2, H3 plus this is again G, this is again G. In case of H, you have H2. Understanding? This way we are going to calculate. Again, you calculate this and simplify it. You will get the final transfer function as this. There will be some cancellation happen. Then you will get that final transfer function. Now we will consider station B. For considering station B, if you see, the station A need to be made 0. So we remove that station A. This G2, G1 is directly connected to H2. These all are same, but this station B is connected and this took as the input R. Now how to do? If you see G1 and H2, G1 and H2 are what? How they are? They are in series or cascaded. So we can multiply them. So we can multiply that, and multiplied equation how it is written, C2 minus G, this is minus H2, so it is minus G1 H2 is written. Then what they have done here is, as input is here, output is here, that input side we have took it here, this input side we have took it here. So that input side has what? G3 and C2 remaining. To this point what is connected? Plus this summing point and G2 and H3 and this minus plus and minus G1 H2. See, this whole thing they shifted downside. Okay. Please understand here. I will repeat once again. This is input and this is output. Sorry. This is output. Right. So this input, this output is kept as it is. This G3 also kept as it is. The remaining part what is there? No, that they have took it down. Nothing but this is connected to plus, so took plus. then another summing point, took that summing point, then G2, where that is connected in forward loop to H3. So that is also considered. Here if it is like this, if down it will become input to output. So it is from input to output you will consider. Then you have minus G1 into H2. Why? Because they are cascaded. After writing this, if you see here, these summing points have been shifted. So you will get H1 G by G2 and minus G1 H2, G2 and H3 G3. And after writing that, if you see here, this if shifted, this summing point comes to left side, this summing point goes to right side, then what happens? This will be in the this is not in feedback loop, this is from the output input to output, so it will be parallel, and this is also from output to input, so we need to take transfer function. After taking transfer function and adding them, you will get in this way. After getting this G3, and this is in form of transfer function again. If you see here, you can take easily transfer function formula. If you take this as G and this as H, you can write G3 by, as here plus is given, you will take here minus. Then what is G? G3 is the G, and H is what? Minus G1, G2, H2 minus H1 by 1 plus G2, H3. You will write it. If you continuously calculate, you will get this as transfer function. You should calculate until you get the final answer. Keep that in mind. Next question. For system represented by the block diagram shown in figure, determine A C1 by R1 and then C2 by R1. When you want C1 by R1, you need to make R2 and C2 as 0. So how it happens? C1, this H2, H1 is connected directly to G5. As C2 will be 0, this G6 also will be 0. So we will remove that G6 part, and this H2 will be connected to the summing point of the G4. Again this will become 0. See, here we are considering R2 0, means this whole thing will be removed. So this H2 will be directly given to this summing point. Okay. If you see here, why? Because we want C1 by R1. Understanding? Other C2, R2 need to be removed. From here, if you see, this G4, this G1, G2 is written in the same way, G3, and this H1, what they have done here is, H1 summing point is connected to what? G5. This G5 is connected to G4 by 1 plus G4. Why? Because here there is a feedback of signal 1 here. If you see, this is the feedback of signal 1. So it is of G4 by 1 plus G4 H actually. In the place of H there is no H value, it is 1. So it is 1. So G4 by 1 plus G4 is connected, and for that again what is connected? H2 is connected from between G1 and G2. After connecting this, R1 input is same and G1 is same. If you see here, these all are in cascade. If you see, so you can write G4, G5, H1, H2 by 1 plus G4 by multiplying all of them. Then from this, what you have, from G2 there is a connection to the summing point. Okay, nothing but from the output to the input. So first you will take this as G and this as H and write G by 1 plus GH. Then after that, if you see, G2 is multiplied to it, you can multiply that to that, and then again if you see, this whole thing is in the form of G. 1 minute. This whole block is in form of G, and there is a transfer function, there is a feedback of 1. So you will get g by 1 plus g into 1. So you will write the g terms in that equation, and then after writing in this way, g3 is in cascade form. So you will multiply this with g3. Okay, multiply this with g3 to this whole equation. Then you can do some cancellations and multiply the thing. You will get the transfer function as like this. Now determination of C2 by R1. You want C2 and R1. So C1 part, this G3 part need to be taken out and R2 part need to be taken out. See here. Understanding? So G3 part is not there. R2 part is also not there. This G6 is present now. From here, if you see here, again this will become G4 by 1 plus G4. First you consider that. See, G6, C2 will be the output, G6 and G5. G5, from G5 there is a H1 which is connected to the summing point. Okay, make it easy. So they are doing this. Okay, after G5, G4 by G1 plus G4. Again that is connected with H2 in the forward direction. From G1 it is connected. So directly from G1 it is connected. And G2 is connected in the way that in the backward direction. Okay, G2 is connected in this way. So we are connecting in that way only. From output to input it is connected. After writing in this way, simpler way, from output to input if you go like this, then you can easily make connections accordingly between what and what. Then if R1, then what happens? This is in the form of G and this is G2 is H. So G1 by 1 plus G1 G2. Then after writing, there is H2, G4 by 1 plus G4 and G5. These all are in cascade, so you can multiply them. If you multiply them, you will get G1, G4, H2, G5 by 1 plus G1, G2 into 1 plus G4. Then multiplied with G6 by this is H1. So this is again in the feedback loop. So you can consider this whole block as G again. This has H. Then you can write G by 1 minus GH. Why? Because here it is plus, so you should write minus. If you see here it is given 1 minus the whole thing G, this is whole thing G, 1 minus G into H is H1 and that is multiplied with what? G3. After writing this, you can multiply this whole thing with G3. Why? Because they are in the cascade. So this is the whole equation what you will get. Understanding? Little bit tricky these questions are. You should know the concepts, how to shift, how to write. Should be familiar means you need to write and practice. You need to practice these sums. So any of the sum given you can do. You should know the concepts and you should write and practice. So by this we completed block diagrams and all the topics. In the next video I will start the signal flow graph. So for now I will stop the video. So please do practice. If you have any doubt you can ask me in the comment box. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.